Hello, and welcome to a history of the hypothetical Planet X, a prospective ninth planet in our very own solar system. With an orbit so potentially strange and anti-aligned with our own that it has only been speculated by math and never actually seen by human eyes. My name is Professor Plan E. Terry, galactic local and cosmic enthusiast, but you can just call me Terry. And I'm here to give a breakdown on Planet X's history of theorization, from the initial speculation that led to many incidental discoveries, all the way to the highly advanced modern math implemented today to speculate its approximate position. So, with all that said, let's all start at the beginning, where the proverbial X marks the spot, with an influential 20th century astronomer named Percival Lowell. Around the year 1902, Percival Lowell, a prominent American astronomer, speculated about the possible existence of a ninth planet beyond Neptune, based initially on the perceived relationship between the orbits of comets, meteor showers, and even our own distant icy planets. Though he was certain of a Planet X being out there based on his speculative calculations, with limited technology and staff, nothing conclusive was initially found. Then, in 1910, he was spurred by the news that an astronomer at Harvard College Observatory, William Pickering, who had previously helped Lowell establish his own observatory, was also looking for a planet. Lowell then put his efforts into high gear. He got more sophisticated telescopes, hired several highly advanced mathematicians, who he deemed computers, and purchased a device called a blink computer, otherwise known as a blink microscope. A device designed to compare two images of space taken at different times by rapidly going back and forth between the two photos taken at different times of day. However, even equipped with all this technology and passion to discover the mysterious and unseen Planet X, he was unable to discover anything there before his passing in 1916. 14 years after the passing of Lowell, using the blink computer purchased beforehand, a planet past Neptune was discovered, not only right around where Lowell himself was searching, but at Lowell's very own observatory as well. Clyde Tombaugh, known for his work on farms, then observatories, discovered what he had initially wanted to hail as the long-lost Planet X in 1930, until subsequent observations revealed the eccentric orbit and particularly tiny size of the planet would be unable to cause the gravitational irregularities caused by the potential Planet X. Thus, the discovery was given a proper name, Pluto, chosen by an 11-year-old girl out of Oxford, Venetia Burney, who chose the name based on the Roman god of the underworld. But this was not the end for Planet X. Undeterred by Pluto's discovery, and in fact invigorated by the find so far out in our own solar system, various astronomers resumed the search for the so-called Planet X, or really anything else that might be out in that pocket of space. One particular astronomer, Gerard Kuiper, who many considered the father of modern planetary science, theorized that a massive belt of icy bodies lay beyond Neptune, which he saw as his only explanation to the mystery of comets. That being, some comets loop through the solar system on periodic orbits of half a dozen years or so. They encounter the sun so often that they quickly evaporate, vanishing in only a few 100,000 years. Astronomers call them short-period comets. Short-period comets evaporate so quickly compared to the age of the solar system that we shouldn't see any, yet astronomers routinely track dozens of them. It was a real puzzle. Kuiper's solution was a population of dark comets circling the sun in the realm of Pluto, leftovers from the dawn of our solar system, where the planetesimals were coalescing to make planets. The ones beyond Neptune, Kuiper speculated, never stuck together, remaining instead primitive and individual. Nowadays, they occasionally fall toward the sun and become short-period comets. However prophetic his prediction, he did not live to see his speculation come to fruition, passing in 1973 before the work of a dynamic duo of scientists could prove him correct a few decades later. Dave Jewett and Jane Liu A pair of scientists who didn't believe the outer solar system was empty began their search in 1987, scanning the heavens in search of dim objects beyond Neptune. It took 5 years, looking on and off through the University of Hawaii's 2.2-meter telescope, but they finally found what they were after: a reddish-colored speck, 44 astronomical units from the Sun, even more distant than Pluto. Jewett and Liu wanted to name their find Smiley, but it has been since catalogued as 1992 QB1. Though no matter what they named it, it proved that there were in fact Kuiper Belt objects out in the reaches of our own solar system. And if Smiley could be out there, why not Planet X? As a summary before we move on to the more modern tactics used, the Kuiper Belt is a disc-shaped region beyond Neptune that extends about 30 to 55 astronomical units from the Sun. This distant region is probably populated with hundreds of thousands of icy bodies larger than 100 kilometers across and an estimated of 1 trillion or more comets. Since 1992, there have been continued observations of the Kuiper Belt, and it has unveiled a population of small bodies exhibiting a striking and unique collective structure. Mathematical simulations suggest that approximately a 10 Earth mass planet, dubbed Planet 9, but we will keep calling it Planet X because it's cooler, may sculpt the intricate arrangement of the distant Kuiper Belt. Planet X likely resides in the eccentric orbit that is anti-aligned with respect to the Kuiper Belt objects, yet still in part sharing their moderately inclined plane. These gravitational torques possibly exerted by Planet X would also generate a population of highly inclined centaurs, or small solar system bodies, causing positional changes that can be monitored and predicted. Now let's hear how that math sounds from our resident computer. Want to break down the numbers for us, CompuBot?
150O. Actually, such a scenario is strongly disfavored by the latest constraints on the anomalous perihelion precessions of some solar system planets obtained with the INPOP and EPM ephemerides. Indeed, they yield dx greater than or equivalent to 496 to 570 O, mx equals 2m circled plus, and dx greater than or equivalent to 970 to 1111 O, mx equals 15m circled plus.
What CompuBot is trying to say is that although we have yet to see it ourselves, the possibility of Planet X residing where these anomalies are present is quite high, based on advanced numerical projection. Now, the question you're probably asking yourself, why can't we see it if everyone is so sure it is there? Well, if you remember that eccentric orbit from earlier, it has one other quirk to it, that being the predicted orbit is between 15,000 to 20,000 years, which would explain why we have not been able to observe it ourselves yet, even along its mathematically predicted course. But, perhaps in future lifetimes, using the foundations laid by the scientists before them, the enigmatic planet will reveal itself to us and end this over 100-year-long search. Today, astronomers continue to explore the outer reaches of our solar system, driven by the quest to unravel the secrets of Planet X and, of course, other galactic mysteries. Continued analysis of the distant and highly inclined outer system objects offers opportunities to test the Planet X hypothesis further, and perhaps refine our understanding of its orbital elements, chemical structure, and prospective mass. The ongoing search for Planet X may lock new insights and dynamics into evolution of our own solar system, potentially reshaping our understanding of the cosmos. Yet, as of this day, it remains unseen by human eyes. Who knows? Maybe it'll be one of you watching who discovers it. Wait, hold on. I'm just now getting some new information about Planet X. This is unexpected. It says here that Planet X will cause the world to end in the year 2012. Really? Huh. Well, thank you all for joining me on this journey of mathematical prophecy and accidental discovery. And always remember, don't panic. Bye.